Good morning. You're welcome to today's class. All right. You said you guys did. Where are you? You are in discussing laws of indices, right? You were giving the laws of indices, right? Huh? All of them. How many are they? 9 or 8? How many are they? Is there any issues you have there? Any question you want us to solve there? Because I wouldn't want us to go and study, because this is a tutorial class. You've done that in your class. So we just look at questions. Then from that question, I can now explain one or two things to make you understand it. Is it clear? So is there any question you are giving, or any question you want me to solve? And if there is, let me say it, please. So the topic is indices, laws of indices. So we take it from there. Let me see if there's any question. Let me see it. Which one is that? This one. Okay. So the question says 81 over, is this step 16? Or is it equal to minus 3 over 4? Okay, look up. Everything here is considered a particular number, right? We can consider this as a particular number. Then there's this law of indices that states that if you have something like this, a raised to power b over c, a raised to power b over c, is that now saying root a, c will be here. All raised to power what? B. True or false? Good. There's a law that states something like this, right? Now, if it's like this, because what is there is not minus. Once you put negative here, it becomes inverse. So if you put negative here now, if you have something like this, if you put minus here, we have something like this. This will be an inverse of this. That means 1 over this one. This thing now, this minus will now give you something like this. 1 over what? C. Is it clear? Is it clear? Now, with this at the back of our mind, we can solve this question. It's simple, right? But it looked difficult, right? But it's simple. So if you apply this rule here now, you have something like this. Can I clean here, or would you want to put it down? Is this your notes? Okay. You can put it down in your notes. So with this now, we can use this law to solve this question. Put it down fast. Let's continue. How are you? We are done. Good. So I can now clean it. So let's now solve this question. Let's now solve this question. So we get that law I stated now. This thing will now take this shape. 81 over what? 16 in roots, inside the root. This 4 will do what? Come here, right? This 3 will become the what? Power. Is it clear? Is it clear? Good. So for you to solve this thing, first solve everything inside this place. Start from the one inside. Solve everything inside this place. Start from the one inside. All together. Then you can now get the what? The power. Is it clear? Now, let me give you also another example. Had it been what is here is 2. Let's assume what is here is 2. What is here is 2. It becomes square root. But this is 4. Cube root, 4th root. Okay? So what happened is this. What do you understand by square root of a number? A square root of a number is a number that you multiply twice to get the number in question. Square root of a number is a number that you multiply twice to get the number in question. For example, now 4. Square root of 4 is 2. Because if you multiply 2 twice, you get what? 4. Is it clear? What is the cube root of a number? Cube root of a number is a number that you multiply 3 times to get the number in question. Something like 8 now. What is cube root of 8? It's 2. Because if you multiply 2 3 times, you get what? 8. So now, if you want to find this 4th root of this and this now, what you do is that what number will you multiply that multiply itself 4 times to get 81? And what number will multiply itself 4 times to get 16? Tell me. You must not punch your calculator. Tell me. Tell me now. You must not punch your what? Calculator. Tell me number that multiply itself 4 times to get 81. 3. Let's check. 3 times 3. Don't touch that calculator. 3 times 3 is what? 9 times 3 is what? 27, right? 27 times 3 is what? 1, 2, right? 3 times 2 is what? 6. 6 plus 2 is what? 8. So 81. So here, what should be here is what? Everything is still under this 3. Remember? So here should be what? 3, right? So what number will multiply itself 4 times to get 16? 2. 2 times 2 is what? 8. 8 times 2 is what? So 2 times 2 is what? 4 times 2 is what? 8 times 2 is what? So it's 2. So here is 2. Is it clear now? Is it clear now? Good. So now we now have 3 over 2 raised to the power of what? 3. So what you now get the power of 3. So now that means we multiply this one. This one will multiply itself into 3. And this one will multiply itself into what? Into what? 3. They belong, this 3 is one of them. That's why you have big bracket. Had it been is like this now. Had it been is like this. Had it been is like this. You know it belongs only to what? 3. But because it covers both of them, so this 3 we multiply itself by 3 into 3. These 2 we multiply itself. It's not 3 times 3. It's not 2 times 3.
I know 3 times 3 times.
Good. So let's do it. So this is now equal to what? 3 times 3 times 3 over what? 2 times 2 times 2. This one is what?
2 times 3.
9. 9 times 3 is what? No, don't tell it. 9 times 3 is what? 9. To what? No, 27 now. 9 plus 9 plus 9 is 27. 9 plus 9 is 18. 18 plus 9 is what? 27. So here is what? 27 over what? 2 times 2?
4.
4 times 2?
8.
8. 27 over 8.
That's the answer.
Huh?
That's the answer.
But this is always good to leave it as a mixed what? Fraction, depending on how they want it to be. But if they didn't tell you how it should be, you can leave it as a mixed what? Fraction. That means if you divide 8, if 27 divide 8, how many 8 can we find inside 27 as a whole number? 8 is 3 now.
3, yes.
So we have 3 whole number. What is remaining? 3 times 8 is 24, see?
Yes.
Subtract it from 27. What will remain? 27? Huh? No, now we want to move this to mixed fraction.
Okay.
We divide 27 by 8. We have 3 whole number. That 3 number, that 3 times 8 is 24 now, right? Yes. So we have 8 as a whole number into 3 inside 27, and that 8 into 3 is 24. 8 times 3 is 24, right? So what will be the remainder? You subtract that 24 from 27. 3, right? So that 3 we place in the what? Numerator here. Become 3 over 3 over what?
8.
8.
But if you want to leave it 24 over 8, you will get the answer.
27 over 8. This is the answer, but it's always not good to leave answers like this. What happened?
But if I leave it like this in the exam, they don't mark it.
To me, if you're writing an exam for me, you must break it down like this. Unless I ask you specifically, leave it out as a decimal form, but it's always good to leave the answer like this. It's not good to leave the answer like this. Just bring it down. Is this an assignment you are giving or what? Or classwork?
It's classwork.
So how he solved it for you?
No, you just leave it down. That is 27.
Yes. But that answer, right?
Yes.
That I'm saying now. In mathematics, it's always maybe he left it there because breaking it down for people here, some may get confused. But with this now, you will now know what I mean by, at least from what we did now, you will now know what is improper fraction and mixed fraction. I might complicate it. But if I'm going, you're writing an exam for me, don't leave the answer to me like this. You must break it down to mixed fraction. But not that this answer is wrong though. I might complicate it. That's the answer. But this and this are the same thing, hope you know. But I prefer leaving my answers in what? Improper fraction. Sorry, I mean mixed fraction. This one is improper fraction because the numerator is higher than the what? Denominator. Yes. Is it clear? Okay. Any other question that's confusing you then? If there's another one, bring it up, please. Let's talk to. But talk it to one first. Then check if there's any other question that you have any issue to. But you now understand this one, right? So if it comes out, can you tell me if there's any mistake here? Thank God, I like this thing that happened now. Can you tell me if there's any mistake here? I like this thing that happened now. Hey, I love this thing. Thank God for this mistake I made here. Tell me if there's any mistake here. Tell me. There's a mistake here. Yes. See what I solved. I solved 81 over 16. This is what I solved. This is what I solved. I didn't put into consideration this minus sign here.
Okay, there's no minus sign there.
I mistakenly omitted this minus sign and solved for this one.
Okay, because there must be a 1.
There should be an inverse.
Yes.
So if anything, what I solved is correct too, we try to but this is what I solved.
Yes.
So if I now want to solve this one, this minus should be here.
Yes, and 1.
This minus should be here. And it now be something like this. 1 over
81.
One over what?
27.
3 over 2. This minus should
But you start placing 1 from there instead
Huh?
of here.
So-
1 should be here.
one should be where?
Up.
What I put it here, it will still give you the same thing. Have you seen the mistake? I'm very careful. I know it too, but did I fail it? No.
Not for it, the answer.
Had it been this was to be exam, I failed it.
Yeah.
So in exam you can fail what you know.
Just one,
You can that one rendered it wrong. If not, the answer should be like this. If you work here now, the answer should be what? Invert. Everything should be invert. It should be what? 2 over 3 raised to what? 3. Which is now what? 8 over what?
27.
This should be the answer. Is that what you got?
Yes.
But what I saw is this one. This one, see the answer here. But this one, see the answer here. Is it clear? Is it clear?
Okay, this 2 now. Okay, you turn it upside down.
Yeah, that's why that minus here means inverse.
Inverse. Okay.
So be careful. That was the mistake I made. Be careful. Be very, very careful in solving a question like this. You may know it and make a mistake. But I'm happy, at least I will use it to explain something to you now. At least I will use it to explain something. Is it clear? Good. I like this question. I was really sorry. I forgot my negative side here. So the answer is actually what? 8 over what? Now,
if it's that way to 27, you will not do it like
no, now, because this one is a proper fraction. Listen carefully. No need, because it's a proper fraction. A proper fraction, the numerator is less than the what? So it's proper. No need working on it again. But if let's assume you did this one, the one I saw, I will end up here. And the answer will be this. So, but what we are solving in this one, do you hope you don't understand the two of them?
Yes.
You don't understand the two of them, right? Thank God for that. So get another question if there is another one you want us to solve. Are you done? All right, so let's look at this one. Let's look at this one. Is this a? Is this raised to power? So it should be like this. Okay? Why this should be like this? This should be up. Is it clear? Now, there's law of indices there's law of indices that says that if you have s raised to power a, sorry, a raised to power c times b raised to power b, he said now saying a, sorry, a raised to power d times a raised to power d, he said now saying a raised to power c plus d. Have you come across that law of indices? Good. And there's also law of indices that says that a raised to power c divided by a raised to power d is equal to a raised to power c minus d. Have you come across it? This one also exists. if two numbers are raised to power, they have different powers. If you divide them, you pick one of the numbers and subtract the what? Powers. Use the power below, subtract the power. You know, we know that this division is the same as saying, A raised to power C over what? Hope you know. Know it today. This is
But you have the same number now, you just pick one.
I'm trying to tell you why it's like that. This is division now. So this is what? Division. So you now pick one, subtract this from this. You now have what? C minus what? D. Is it clear? Now to solve this question, we use BODMAS. Remember our BODMAS. You know BODMAS now? In your primary school mathematics, BODMAS. Brackets of division, multiplication, addition, and what? Subtraction. But anyway, anyone can go share. Whether you multiply and divide, they can go. So let just.
Okay, for here now.
Yeah.
That times now turn to plus. Division turn to minus.
For the power.
Yes.
So here now, what we know this is certain as saying A raised to power 1 over 3 times A raised to power 2 over 5 over what? A raised to power. Hope you know. Division now.
Yes.
This is divided by this. Hope you know. Now, remember that law, this law. Now, let's now work on this law. A is here, A is here. So we have A raised to power what?
1 over 2.
Plus what?
2 over 5.
All over what?
1 over 2.
Is it clear? So, let's solve this power using fraction method. Let's solve it with fraction. Yeah. 1 over 3 plus 2 over 5 is what? What is LCM?
3.
3 1. 5 1. 15 now. It's 15. There's nothing common. There's nothing common. Both of them can divide. So it's 15. You simply multiply them. It's what? 15. Is it clear? Okay, you don't know how to solve LCM.
LCM, I know.
Yeah, now. LCM means lowest common what? Multiple. And what is a multiple of a number? What is a multiple of a number? Okay, no problem. A multiple of a number, let me use 2 and 4 now. 2 and 4. 2 and 4. 4 is a multiple of 2. And 2 is a factor of 4. 4 is a multiple of 2. So a multiple of a number is a number that you can multiply the number to get. Am I conjugating? I can have 2 now. 2, you can multiply. If 4, if 2 is a factor of 4, then 4 is a multiple of what? Just the opposite of it. 4 is a multiple of 2. Am I computing? Okay, in a nutshell, if a number like now 4 now, 2 can divide 4, right? Comfortably. So 2 is a factor of what? 4. And because 2 can divide 4, 2 is a factor of 4. And because 4 can be divided by 2, so 4 is a multiple of what? 2. Is it clear? Is it clear? Good. Now, multiples of 3. If you say LCM, lowest common multiples, you have to check multiples of 3 and check multiples of 5. Then their lowest common multiple. If you check now, these 5 and 3, they have no common multiple. The lowest common multiple means that the number they can divide. The only number 2 of them can divide is what? 15 now. True or false? The lowest number, not the only, the lowest number two of them can divide is what? 15. Two of them can divide 30, hope you know. But 30 is not their lowest number they can divide. So the lowest number they can divide is what? 15. So that's why 15 is their what? Are you following me? Let's see. I don't want to do it like that one you were doing in your promise to withdraw and I want you to understand it now with a mature mind. Not that one you are drawing. Is it clear now? So that's what it means. LCM, lowest common multiple. Lowest number, two of them can divide easily is 15. They can divide 30. They can divide 45. True of us? 3 divided 45 is what? 15. 5 divided by 45 is what? 9. They can divide 30 is lower than what? 45. But they can divide 15. 15 is the lowest they can divide. Common. So it's 15. So let's now start. 3 divided 15 is what? No. How many 3 can we find it inside 15? 5, good. 5. Sorry, 5 times 1 is what? That 5 times this one is what? 5. Plus 5 divided 15. How many 5 can we find inside 15?
5.
How many 5 can we find? How many 5? What are they saying? 3. So 3 times 2 is what?
3 times 2 8.
Hey, what are you saying?
16.
3 times 2 is 16.
3 times
3 times 2 is what? I want to read. Tell me. 3 times 2 is what?
9 now.
3 times 2.
Okay. 8 now.
3 times 2 is 8. What are you saying? Calculator has 40 people. What are you saying? 3 times 2 is what? What do you understand by 3 times 2? Let's even start from there.
3 I test by 2.
You times 3 by 2.
Yes.
Then do it now. What is the answer?
I use calculator.
Don't use calculator, please. Stop.
That's nice.
It's what?
6.
6. Good. So 6. So yes, now 5 plus 6 is what? 5 plus 6 is what? Is what? 11. So we have 11 over what? 15. So here is what? A raised to what? I follow you. All over what? A raised to 1 over 2. So we now use this second one to solve this question. Is it clear? So this one now becomes A raised to 11 over what?
15.
Minus what? Look at this law now. Minus what?
Minus A over 1 over 2.
What are you saying? Is that what is in this law? Check well now.
1 over 2.
Minus 1 over 2, good. So we now solve this fraction and get the answer. So the fraction now, this one, let's solve it. 11 over what?
15.
Minus 1 over what? 2. What is the LCM of 15 and 2? What is the common multiple? Lowest common multiples of that means the lowest number two of them can divide easily without remember. That's the meaning. You see, there no number two of them can divide. Lowest one. There are many numbers they can divide. Though. The lowest of them is 30. Lowest of them is 30. So simply do 5 times 3. 30 is the lowest number people can divide. They can divide 60. They can divide 30. They can divide 120. But lowest is what? 30. So here is what? That 15 divided 30 is what? Good. 2 times 11. Good. 22. Plus 2 divided 30. 15, right? Times 1. God bless you. I like that. Now you come. That's what I want to be seeing. Minus what? 15, right? So 22 minus 15 is what? 22 minus 15 is what? Do it now. Just simply do like this now and do it now. What are you doing? Is it 7? Good. 7 over what? That. Is there anything you can do? No, nothing can go here. So leave the answer like this. So here, because the answer now becomes what? A raised to power what?
7.
That's the answer.
This one too.
Okay, this one I saw is too long.
Okay, you break it down here.
You're supposed to understand it now. Maybe you say you didn't understand it. I'm breaking it down now for you. Is it the sincere answer?
Yes.
But I'm breaking it down for you to understand. That's why you are in tutorial. Tutorial is supposed to understand. It's not true. That's why I'm breaking it down step by step so you understand what happened. Are you sure you understood this thing? Are you sure? Okay. Our time has elapsed. Okay, 10 minutes more. Do you have any other question? Put this one down first.
Some.
I don't. Okay. So this will be the last question for the day. Let's solve it. Then we go. When the question says 9 raised to the power 2x plus 1 is equal to 81 raised to the power x minus 2 over 3 raised to the power what? X. Solution. I'm supposed to divide this board into 2. What am I going to do instead? I should divide my board. That's the right thing to do. Alright, so solution. Now, are you with me? So let's try to reduce this, if possible, to 3. as the base, okay? You know that these things are multiples of 3. Because they are multiples of 3, so we can easily reduce them to be of the same base because they are multiple of 3. That makes it easier for us. 9 is a multiple of 3. 81 is a multiple of 3. So we turn this 81 to have base as 3. Then we now shift the power, the index. We turn this 3, this 9 to have the base of 3. We move the power, so we can easily solve it. Is it clear? Now, remember that 9 is written as 3 raised to power what? 9. How many times will you multiply 3 to get 9?
2.
This is 3 raised to power what? 2. 81. How many times will you multiply 3 to get 81?
4.
So 3 raised to power what? Is it clear now? Is it clear? Are you sure? Alright, so now, anywhere we see 9, we put this. Anywhere we see 81, we put this. So let's go. Here now, here becomes 3 raised to power what? 2. Is it clear? 2s plus 1. Is it clear? Is now equal to what? Let's replace 81 with this. So we have 3 raised to power what? 4. S minus 2. All over what? 3 raised to power s. You understand what I did here? So let's now use this 2 to multiply everything here to open this bracket. So this becomes now 2 times 2x 4x 2 plus 2 times 1 2 is equal to 3 raised to power 4 times x 4x minus 4 times 2 8 all over what? 3 raised to power what? X. Is it clear? Is it clear? Let's solve this one like you using that law of indices. Remember that law that said that if you have a raised to power b over a raised to power what? C, we have what? A raised to power what? B minus C. Is it clear? So let's use that to solve this one. We bring out 3, subtract this from this. So we have something like this. 3 raised to power 4 3 raised to power 4x plus 2 is equal to what? 3 raised to power what? 4x minus 8 plus what? Sorry, minus 8 minus what? Minus s. Good. Let me clean this one. So this now becomes 3 raised to power 4x plus 2 is now equal to what? 3 raised to power 4x. Sorry, this 4x minus x is what? No. 4x minus x is what? 3x.
3s.
Yes.
Okay, yes.
Because here is 1, but you cannot see it. And if you bring out x, there's s here, there's s here. If you bring out s, you have 4 minus 1. 4 minus 1 is what? 3 times s, 3s. Is it clear now? So yes, 4s minus s is what? Is what?
3s.
3s minus what? 8. Is it clear? So they now have the same base. There's also another law. If you have A, you put it out, this is I'm breaking out step by step. Hope you put them down. If you have something like A raised to the power B is equal to A raised to the power C. Look up. This base can cancel this base. What means that B is equal to what? C. Is it clear? Understand that one? So, because of these two things now, 3 will do what? So 4x plus 2 now become what? 3s minus what? 8. We collect like terms. Oh, is this going? We collect what? Like terms. So x, 3s will come to this side. 2 will go here. So here become 4x This, huh? What's that? Any problem? This is not writing well again. Okay, let me just manage it. But you can see it now, right? Now, 4x plus 2 is equal to 3x minus 8. You correct like terms. S, 3x will come to this side. 2 will do what? So if 3x here is positive, now if it comes, it becomes what?
So it will be 4x plus 3x.
Plus again, there's a plus here. If you cross this sign, it becomes what?
Times.
Minus now. Minus. Here is plus here. This is plus 3s. Even though there's no plus here, but once it comes to this place, it turns to minus 3s. So here becomes what? Minus what? 3x. It's equal to. It's equal to. It's equal to. Look up. Here is minus 8, right? Plus 2 come to this side. It becomes minus 2. Huh? This is 2 now, not 8. Do you know what we mean by collection of light terms?
Yes.
What are you saying? If you want to collect light terms, this has no x, but there's x here. So this one will come to the one that has x. But if you cross this sign of equality, their sign will change. If 3s crosses here, it will change to minus 3s. This 2 here has plus sign. There's already minus 8 here. If this plus 2 goes to this place, it becomes minus 2. So here is minus what? 2. Is it clear? So we have 4s minus 3s is equal to minus 8 minus 2. 4s minus 3s is what? Use what I did here now to answer that question. Is what?
It's 1.
1. Or x. 1s, which is x now.
Yes.
You don't say 1x. I just put it here to explain something. They're not there. This one is invisible. But I put it here because I want to use it to explain something to you. So what happened here is the 4s minus 3s is what? Just x.
The minus 3 from is 1x.
You don't say 1x.
Okay.
This one is invisible. I intentionally put it here to explain something to you.
I know, but here is 4s minus 3x. So if you minus 4 from 3,
It's 1s. But the answer is what? X.
Okay.
We know it's 1x, but don't say 1x. If you say 1x, answer they laugh at you. Just say x. Everyone know that it's 1x, but just say what? S. Is it clear?
Yes, sir.
I like what we applied though. But when writing, don't write 1s, just write x. Had it been is 2 up, you can write 2s. Is it clear? So here is what?
X
S is equal to what?
minus
Minus 8 minus 2 is what?
minus
Minus 10. Okay. Minus means that you are owing me, right? You are owing me 8 naira. Minus 2 means that you are owing me under 2 naira. So how much are you owing me? 10 naira. So it's minus 10. Is it not? So this is what minus what? 10. So x is what? Minus 10. That's the answer. Is it the same thing there?
Don't break it down like this.
But is it same thing there?
Yes, I understand.
Please, that's why you are here. You learn. Tutorial is where you cool down. You know, watch now. We cool down. We are in one question for like how many minutes? Lecture period is just 1 hour. You may not be able to do everything in lecture because of time. That's why you go for tutorial for those that want to go. Am I complimenting? So you are here for it to be broken down small in the way you understand. So don't compare tutorial with that. Tutorial is for normal class. Am I communicating? So that way, anyway that they talk about tutorial, if you have the time and the money, go for tutorial if you have it. It helps for understanding. And say, you know, doing lecture hall, there are some questions you cannot answer. You cannot ask. Maybe you are afraid that if you ask it, they're laughing at you. They'll be like, where is this one coming from? Are you sure this one wrote WAEC? You will be ashamed to ask it, true of us, but you ask it in a place like this. So the answer is what -10. I think we'll stop here for today. Thank you very much for your attention. Please study. Don't waste your time. Please study. God bless you. Go for your lectures. So listen. But that doesn't mean you should not ask also in class. So whether they laugh at you, ask it. No problem. If they laugh at you, you learn it. All right. See you next time.
Thank you, sir.
You're welcome.